Hello everyone, you're welcome to this live lesson. Sorry, we had a little challenge, so that is why we are starting very late now. So I don't just want to cancel this lesson, so we'll just look into loss of indices. So next week we'll look into some examples and past questions. So in the next 2 minutes by 6:15, so the live lesson will commence. Thank you. Hello everyone, so you're welcome to this lesson. In this lesson we'll be discussing lots of indices. You should already know index form. So when you have a base and a power, so take for example a to the power of m. So the a here is referred to as the base and the power here is m, and you could call it exponents, and you could as well call it index. Okay, so if you have something like this, then you have an index and the plural will be indices. So we are going to look into 6 laws of indices, okay, and the illustration, and next week we are going to cite some examples and look into some past questions because we are seriously late for the lesson. Okay, so we're going to look into the following laws. The first one is multiplication law of indices. Then the second one will be division law of indices. So the third one will be zero index. Then the fourth one will be negative index. The fifth one will be fractional index. And the sixth one will be power law. So for you to understand indices very well, it is very compulsory for you to understand and illustrate the following laws of indices. So once you can do this successfully, you can state the law, you can state the illustration, then any question on indices that comes your way will be very simple, because everything about indices has to do with these laws, okay, and once you master them, then you don't have any challenge. So we will take them one after the other. Okay, so when we have 2 indices, so the first one will be multiplication law of indices. So if you have 2 indices, take for example a to the power of m and another one a to the power of n. So we have 2 indices. So if they are separated by sign of multiplication, okay, then we apply multiplication law of indices. So in this case, we are going to select one of the bases, that is a, then we add the powers. So that is what multiplication law of indices tells you to do. When the bases are equal, then you pick one of the bases, then you add the powers. So take for instance, you have 2 to the power of 3 times 2 to the power of 2. So in this case, we have the same base. So you pick one of the bases, then you add the power. So that will be 2 to the power of 5. And this one, 2 to the power of 5, does not imply 2 times 5. Never. So rather, it means 2 by 2 by 2 by 2 by 2. So this one tells you to multiply 2 by itself these times. Okay, so that will be 2 times 2 4, 4 times 2 8, 8 times 2 16, and 16 times 2, that will be 32. So that is the value of 2 to the power of 5. So that is multiplication law. Okay, so still a multiplication law of indices. So let's say we have something like this, a number and then a letter. You have 3 m to the power of 4 times 2m to the power of 2. So in this case, what you need to do is to multiply the numbers. That is 3 by 2. You can put it in a bracket if you want. Then what you have left is m to the power of 4 times m to the power of 2. So this is how you deal with question like this. Okay, so this one will be 3 times 2, that will be 6. Then you can apply multiplication law of indices on these two indices. So this will be m, you pick one of the bases, then you add the powers. That will be 4 plus 2, and that will be 6 to the power of what? 6m to the power of 6. So that is another scenario when it comes to multiplication of indices. So what if you have something like this? You have a to the power of m times b to the power of m. So how do you deal with this? So when you have something like this, so it's going to be a multiplied by b, then they have the same power. Okay, take for instance, you have 2 to the power of 3, then times 3 to the power of 2, to the power of 3. So in this case, you can easily say 2 times 3. Okay, you multiply the numbers, okay, and then you pick one of the powers. So it will be to the power of 3, and this will be 2 times 3. This will be 6 to the power of 3. So this one tells you to multiply 6 by 6 by 6. So it will be equals to 6 by 6 by 6. So if you do 6 times 6, that will give you 36. Then 36 times 6, so that will definitely give you 216. So that is 216. That is the value. Okay, so I've shown you 3 different things now. Okay, but before we proceed, you can easily check this. If you have 2 to the power of 3, you can do it separately. So to confirm your answer, so 2 to the power of 3 means 2 by 2 by 2, and that will be 8. Then times 3 to the power of 3, that will be 27, right? So if you multiply the 2 together, so this will be 27. That's 3 to the power of 3. So if you multiply these 2 together, you still have 216. You can see you still have the same answer. So in summary, your multiplication law of indices could come in 3 different forms. So you could have a to the power of m times a to the power of n. So you have 2 indices separated by a sign of multiplication. Then what you will do is that you pick one of the bases and you add the powers. So this is the first category regarding multiplication law of indices. So the second one is when you have coefficients, okay, of the of each of these. That is, if you have 3 a to the power of m then times, let's say 2a to the power of n. So in this case, you have to firstly multiply the numbers by saying 3 by 2. Okay, then you now have this and this left. Then you can say a to the power of what? M plus n, by applying multiplication law of indices. That is the second category regarding multiplication. So the third category will be when the bases are different but the powers are the same. So take for instance, you have a to the power of m times b to the power of m. So in this case, the bases are different but the powers are similar. So what you do is that you multiply out the bases a by b, then you pick one of what? One of the powers. Since they are the same, it will be like this. So these are the three categories you have here. Okay, so let's add another one to make it 4. So let's say you have a to the power of m, then you have b to the power of n. So in this case now, so you cannot multiply the bases. You can, this will not be correct. You can say a by b, then to the power of what? M times n, or m by n. So this will not be correct. Okay, so we are not looking into this. So we are just looking into these three categories. That is, when they have the same, when the base when the bases are the same, and you just pick one of them and add the powers. And when you have the same, when the bases are the same and you have numbers attached to them like this. And the third one, when the bases are different but they have the same power. So these are the three categories you have here. Okay, so let's go to the second law of indices. In this case, it will be division law of indices. So here, if you have two indices, okay, take for instance a to the power of m and a to the power of n. So if they are separated by sign of division, then you apply division law of indices. So you select one of the bases, then you subtract the power. So this is what division law of indices tells you to do. You pick one of the bases and you subtract the powers. So take for instance, you have 3 to the power of 5, then divided by 3 to the power of 2. In this case, you have the same base, so you pick one of the bases, that's 3, then you subtract the power. That will be 5 minus 2, and that will be 3 to the power of 3. And in this case, this does not mean 3 times 3. No, it means 3 by 3 by 3. And if you do that, 3 by 3 gives 9. 9 by 3 gives 27. So similarly, you could also have the second category, that is where you have 3, for instance now, or let me say you have 27a to the power of, let's say, m, then divided by, let's say, 9a to the power of n. So in this case, you need to divide the numbers first by saying 27 divided by 9, or 27 over 9. They are both the same. So now you are left with these two indices. Then you can say, you cannot apply division law of indices by saying a to the power of what? M minus n. Take for instance, if you have let's say 50 c to the power of 5, then divided by 5c to the power of 4. So if you want to do this now, so you need to divide the numbers first. This will be 50 divided by 5. Then you can now apply division law of indices on these two indices. So this will be c to the power of 5 minus 4. You pick one of the bases and you subtract the power. So in this case, it's going to be 5 goes in 15 10 times, then c to the power of what? 5 minus 4. So that is the second category. So in summary, if you have m to the power of b, then divided by m to the power of t. Okay, so what you should do, so if you have m to the power of b divided by m to the power of t, so what you should do is that according to the according to the division law of indices, you pick one of the bases, then you subtract the power. Then that's the first category. The second category, if you have let's say you have x m to the power of b divided by y m to the power of t. So the first thing you need to do is to divide these constants here. X and y will be constants, okay, and they can still be like these two. They could be variables, okay. So it will be x over y. That is how you deal with that. Then you now apply multiplication law of indices on this and this. So I'll pick one of the bases m, then subtract the power b minus t. Okay. So the next one will be that's the third one. It will be 0 index. Okay, it will be 0 index. So from the word index, you know it means power, and 0 is normal 0, you know. Okay, so when you have 0 index, it means the index is 0, the power is 0, the exponent is 0. So if you have a to the power of 0, so it will be equals to 1. So this is what the 0 index tells you to do. So anything to the power of 0, the answer is always 1. So here you need to be very careful. If you have more than one variable here, okay, so if everything is raised to the power of 0, then everything should be equals to 1. Take for instance, you have a, b, c to the power of 0. So everything is raised to the power of 0. So in this case, everything should be equals to 1. But if part of everything is raised to the power of 0, then only that particular part will be equals to 1, and the others remain the same. Okay, take for instance, you have a, b to the power of 0, then you have c like this. In this case, only b is raised to the power of 0. So that means only b will be equals to 1. That means you're going to have a times 1 times c. Okay, so and this will give you a times 1 a times c, so you have a c. Okay, so that is the answer. So you need to be very careful. One of the mistakes or errors students used to make is when they see power of 0, so they just assume the answer is equals to 1. So you need to be very careful. If everything is raised to the power of 0, then everything will be equals to 1, just like this case. But if part of everything is raised to the power of 0, then only that particular part will be equals to 1, and other variables remain the same. Okay, so that is the third one. So the fourth one will be negative index. You have negative index. Okay, so negative, that means you have negative numbers, you know that. Then index is power. So negative index, it means the power is a negative number. So take for instance, you have a to the power of negative m here. So this is an illustration of negative index. So it means the power is a negative number. So anytime the index is negative, so what you need to do is you write 1 out of, okay, then you pick your base and your power. Okay, so you don't need the negative sign again. Okay, so that is gone. Okay, once you write 1 out of, then the negative is gone. Then what you have left is what? A to the power of m. So take for instance, you have 2 to the power of negative 3. So in this case, this is negative index. Okay, that is the power is negative, and as you could see, you have negative 3. So when you have that now, so you write 1 out of, then that means this one, the negative sign is gone. Then I have 2 to the power of 3 left, and this is equivalent to 1 over, that's 2 to the power of 3 does not mean 2 times 3 is 6, but what? 2 by 2 by 2, and that is 1 over 8. So also here you need to be very careful. If everything is raised to a negative number, then you apply the same thing here. Otherwise, if it is only a portion or a part of it, then only that part will be dealt with accordingly. Take for instance, you have 2b to the power of negative 3. So as you can see here, everything, the whole expression here is raised to a negative power. So we apply negative index on everything, and that will be 1 out of, then that means this negative sign is gone. Then what do I have left? 2b, okay, to the power of 3, and that will be 1 over. So what this implies is that this 3 is meant for everything within this bracket. That means I'm going to have 2 to the power of 3, then b to the power of 3. So this will be 1 out of 2 to the power of 3 is not 2 times 3 is 6, but 2 by 2 by 2, and that is 8, and b to the power of 3 remains b to the power of 3. So in this example here, the whole expression is raised to a negative power, then I applied the law of negative index on everything. But let's say you have something like this. You have 2b to the power of negative 3. Okay, in this case now, only b is raised to power of negative 3. Then I will apply the negative index on only b. So in this case, I'm going to have 2 times b to the power of negative 3. That is what it means. And as you can see now, I will need to apply only the negative index on b. Okay, so this will be 2 times. So the first thing you need to do anytime you have a negative index is to write 1 out of, then the negative sign is gone, then you have b to the power of 3. Okay, then this one is like over 1 now. Then you can multiply the numerators by saying 2 by 1 all over 1 by b to the power of 3, and that will be 2 by 1 is 2 over b to the power of 3. So that is what you need to do. So you need to be very careful. If a particular term out of the whole expression is raised to a negative power, only that particular term should you should only apply the negative index on that particular term. But if the whole expression is raised to the power of negative sign, if the whole expression is raised to a negative power, then everything you should apply the negative index on the whole expression. So you need to be very careful. This is one of the mistakes students used to commit when they are attempting questions on indices. And once you make a little mistake like this or one, then you know the solution will be very wrong. So that is the fourth one. So the fifth law of indices will be fractional index. It will be fractional index. So here, as the name implies, fraction. Okay, it means the power is a fraction. That means the illustration will be a to the power of what? M over n. So that is what it implies. A to the power of m over n. So anytime you have something like this, what you need to do is to draw a root. Okay, anytime you have a fractional index, so the first thing you do is to draw a root like this. Then the denominator of your fraction, in this case n, should come here. Then you can see, what do I have left? A to the power of what? I can put it in bracket like this, a to the power of m. So that is the order you pick them. Let's look into some examples here. So you have 8 to the power of 2 over 3. So you can see the power is a fraction. So the law of indices that is available here is called fractional index. And just like the way you were told, anytime you have a fractional index, the first thing you need to do is to draw a root like this. Then the denominator of the power 3 should be here. Then you are left with 8 to the power of 2. Now, so this is what you have. This one, cube root of 8, what does it mean? It's a command. It's telling you, guy, find me a number that you multiply by itself 3 times, and the answer will be 8. So that is what you have inside the bracket is asking of you. Give me a number that you multiply by itself 3 times, and the answer is 8. So if you start by 1, if you start with 1 by 1 by 1, it will be 1. So definitely it is not 1. So let's go to 2. 2 by 2 by 2. This one is 8. That means 2 is that number. A number you multiply by itself 3 times and you get 8 is 2. So that means the answer within the bracket, the solution to the expression you have within the bracket is 2. And we have raised to power 2 here. I'll just put it here and the answer will be 4. So that is how to express that. That's how to solve that. So let's look into another one. Let's say you have 27 to the power of 2 out of 3. So as it is obvious that the power is a fraction, that implies that we have fractional index. And anytime you have a fractional index, you draw your root like this. Then the denominator should be here. Okay, then you have 27 out of 2 left. So in this case now, this one, what you have within the bracket is a command asking you to find a number you multiply by itself 3 times and you get 27. If you start with 1 by 1 by 1, you get 1. And if you have 2 by 2 by 2, you have 8. So if you do 3 by 3 by 3, you have 27. That means 3 is that number you multiply 3 times and you get 27. So I have 3 here, and the power here, it means to the power of 2. And in this case, we're going to have 9. So this is how you apply fractional index. So let's go to the last one, and that is power law of indices, which is the 6th one. So power law of indices. So the power law has to do with powers. Let's say you have a, b, then to the power b to the power of 2, then let's say you have a b to the power of x, then to the power of y. Okay, so anytime you have more than one power, then you apply power law of indices. So this power of y is meant for everything you have inside the bracket. So that means I can rewrite this one like this. A to the power of 1 is same thing as a, then b to the power of x. Okay, everything to the power of y. So I need to multiply the powers by the power y here. So it will be a to the power of 1 by y, then b to the power of x by y. So that is what you need to do. So you need to use this y to multiply this power here, then you use it to multiply the power here, and this will give you a to the power of y, then b to the power of what? X, y. So that is what power law of indices does. So let's say you have 2x to the power of 3, then everything to the power of, let's say, -4. So in this case now, how do you deal with this? Okay, it's very simple. So you know that this is the same thing as 2 to the power of 1 is same thing as 2, then x to the power of 3, then everything to a negative power like this. So here we are going to have what now? We are going to apply power law because we are dealing with powers. So it will be 2 to the power of 1 by -4, then x to the power of 3 by -4. So we need to simplify this further. So it will be 2 to the power of 1 times -4 is -4, then x to the power of what? 3 times -4, it is -12. So in this case now, you are not done. You can see apply another law of indices there. As you can see, the powers are negative. Okay, so you need to apply negative index. So this will be equals to 2 to the power of -4. Anytime you have a negative power, you were told earlier in this lesson that you just write 1 out of, that means the negative here is gone. Then you have 2 to the power of 4, then times, let's do the same thing for the second one. So x, so this minus here, it will stand for like 1 over, then what do I have left here? X to the power of 12. So I can now multiply the numerators and then multiply the denominators as well. So 1 by 1 will give me 1 out of 2 raised to the power of 4. Okay, is let's say 2 by 2 by 2 by 2 by 2, 2 by 2 4, 4 by 2 8, 8 by 2 16, same thing as 16 times x to the power of 12. So this will be the answer here. Okay, so you need to be very careful. Okay, so if you have a to the power of m times a to the power of n, so this is multiplication law of indices. Why? Because the two indices are separated by a sign of multiplication and the bases are equal, and it tells you to pick one of the bases and add the power. So this is the first law of indices. The second one is division law. When two indices, a to the power of m and a to the power of n, like this, they have the same base. Okay, the power may or may not be equal. When they are both separated by a sign of division, then we have division law of indices, and what we need to do is to pick one of the bases, then you subtract the power. So that is division law of indices. The third one is zero index. So anything raised to the power of 0 is always equals to 1. Remember, if everything is raised, that is, the whole expression is raised to the power of 0, so the whole expression becomes 1. And if part of the whole expression is raised to the power of 0, so only that part will be equals to 1. So that is zero index. The fourth one is negative index. Take for instance a to the power of negative m. Here you just write the minus as 1 over, then what you have left is a to the power of m. Okay, that is negative index. And the fifth one will be fractional index. You have something like this, a to the power of m over n. Anytime you have a fractional index, you draw your root like this. The denominator of the power should come here, and you have a to the power of m left. And the last one is power law. When you have more than one power, like a, b to the power of x, then everything to the power of y. So in this case, this power y is meant for a and b to the power of x. So I will say it's like I'm opening the bracket with the word, with the power. It will be 1 by y, then b to the power of x by y, and that will be a to the power of what? Y, then b to the power of what? X, y. So this will be the end of this life lesson. So by the special grace of God, by next week the same time, we will continue with laws of indices by solving some questions from Cambridge past questions, and then some other questions we could lay our hands on, and we'll also look into equation of indices, which is called indicia or exponential equation. Okay, we're going to look into that, and that will be the end of that topic. So we're going to conclude on this topic next week Friday the same time. So let me once again apologize to all my subscribers that we didn't start at the same time. So there was a technical issue, and that delayed the lesson by 30 minutes. Okay, so if you are a new subscriber, please kindly subscribe to my channel so that you can support my work, and you can share the link with your friends, with your students, so that many people could come and learn mathematics for free. And if you have already subscribed to the channel, please, you can also share it with your friends and let everybody come and enjoy the content here. So until next week Friday, so I want you to, until we meet next week Friday, I want you to practice all these laws, 6 laws of indices. So once you know these 6 laws of indices, so any question on indices that comes your way will be very simple. You should be able to recall and illustrate the 6 laws. So bye bye, see you next week.